going to start recording. See if it actually works for us. So, first and foremost, we need to discuss what a sequence is. For your do now today, you guys looked at 3 different sequences of numbers. So our definition of a sequence is a list of numbers that often forms a pattern. Does it necessarily need to form a pattern? No. Usually it will. And usually that's up to you to figure out what the pattern is going to be. And then your term is each number in the sequence. Okay. So if I'm talking about the first term, or the second term, or the third term, you should be able to identify which number it is I am looking for in the sequence of numbers, in the list of numbers. Okay? So, sequence, terms. So if I use those vocabulary words, you should know exactly what I'm talking about. Right? Got it. Oh, you weren't taking notes there for a second. All right, so don't put that first table down. Let's just talk about it first. So pause from writing. If I give you this table, we have our X, we have our Y. We have our input, we have our output. We have our domain, we have our range. If I have 1 second, my distance is 0.2 miles. 2 seconds is 0.4. 3 seconds is 0.6. 4 is 0.8, 5, 1, so forth. So what's happening each time? I'm adding 0.2. So when I am adding the same number each time, that is an arithmetic sequence. So I would write this down in your notes. Because there's 2 different types of sequences that we are going to hit in this course. The second one is way at the end of the course. So an arithmetic sequence, it's probably the easiest one to take notice to. It's when you have the same number being added each time. So it's when the terms of a sequence differ by the same non-zero number, and we're going to use a lowercase d to represent that number. And we call that d the common difference. The common difference. Okay? So if you can think back to our do now, we had 3 sequences. How many of the 3 were arithmetic? 2 of them, right? The first and the third one were. The first one we were adding, was it 3 each time? And then the last one we were adding a negative a half, right? Or subtracting a half. Okay, so now what's going to happen is we're going to look at a sequence, and you need to be able to tell me whether it is arithmetic or not. And if it is, find the rest of the, oh, what am I doing? I'm writing right now. Find the rest of the terms. All right, so here's your first one. First example. So your sequence is 9, 13, 17, 21. Colin says yes. What are you saying yes to? Is it arithmetic?
Yeah.
Yes. Okay. If so, find the common difference. So we're going to say yes, it is. Colin, what is our D going to equal?
Can you call it Casey?
Really?
Yeah. Yes, please.
Okay.
All right, thanks. It'll be 24.
24.
25.
Well, what's the common difference first?
Plus 4.
All right, so we're adding 4. So my D, remember we're using D to represent our common difference, is 4. So the next 3 terms would be, Zach?
25, 29, and 33.
and 33. Good. Okay. Not too challenging, right? Hopefully not. Okay, so the common difference is 4. My next 3 terms would be 25, 29, 33. All right, next sequence. 10, 8, 5, 1.
No.
10, 8, 5, 1. Seeing some shakings of no's of their heads. Jackson, why did you say no? It doesn't go down by the same number. From 10 to 8, we're taking away 2. 8 to 5, we're taking away 3. 5 to 1, we're taking away 4. So since it doesn't have a common difference, it's not going to be arithmetic. Okay? So we're done with that one. Good. Let's throw some fractions into our lives. 3/4, negative 1/4, 1/4, 3/4. I don't like those fractions. Now, one thing that's nice about arithmetic sequences is you're always looking to see either adding or subtracting. So how do I go from a 3/4 to a negative 1/4? We're subtracting how many fourths? 4/4, which is really 1, right? So we're taking away 1 to go to there to there. Then how do I go from a negative 1/4 to a positive 1/4? So to go from negative 1/4, if I add another 1/4, that would get me to 0. Add another 1/4, so like Chris just said, it would be a half. So do I need to go any further? No. So is it arithmetic? No. Okay. All right, so now you might be thinking, well, what does this have to do with functions? Well, what we're going to end up doing is turning in these sequences into an actual function. So maybe if I'm going to jump backwards, come back to the one that was, there it was. This one was a common difference of 4, right? So we were able to easily predict the next 3 terms, right? That wasn't hard. That was something easy. What if I said predict the 222nd term? What would you do? You would sit there and start writing down all those numbers, right? Until you got to the 222nd. That'd be very, very, very time consuming. Marshall?
Can you go +4 like t per term? Like +4 for each term?
Well, you're thinking in the right concept, Alex.
Use the arithmetic equation.
Yeah, there's a function that we can use to do that type of thing. So here we go. Let's go ahead and get this idea written down. We're going to use the variable a. So we're using a variable a. Is often used to represent the term of the sequence. So variable a, right there. So if you had the sequence, let's say 3, 5, 7, 9. So this is the sequence we're focusing on. All right, I'll pause for a second, give you guys some time to write and catch up. So the variable a is often used to represent terms of a sequence. So if my original sequence, let's say, was 3, 5, 7, 9. Well, that's easy. What would be the common difference? +2. We're adding 2 each time. So what we're going to be using is a with a subscript of 1, which is going to stand for the term in the first position of the sequence. A with a subscript of 2 stands for the second term of our sequence. A with a subscript of 3 would stand for the third term of our sequence. And A with the subscript of 4 would stand for the fourth term of the sequence. Okay, so A subscript 5 would be the fifth. A sub 6 would be the sixth. A sub 10th would be the 10th. A sub 21st would be the 21st term, right? If I said find A sub 50, then that means you're looking for the 50th term. Okay, so this is just notation, making sure you're aware of notation. Well, what happens is, what if we want to find the nth position? So that unknown position that we haven't quite yet picked a number for. In math, we use x a lot of times for variables, but when we're talking about sequences, we use n to represent the nth position. So that's going to become an a sub n. So a sub n represents the unknown term that we probably are going to be looking for. Okay? So I just want to make sure you have the notations figured out. So you use that subscript of your number to represent your term. Okay, so if this was my sequence, 3, 5, 7, 9, what would be a sub 6? 13. Everybody get that to your head? We got that? A sub 6 would be 13. Yes? What would be a sub 7? 15. What is a sub 2? 5. All right, good. So we got the idea of that. All right, so now we're going to take that notation. Is everybody okay? And we're going to use it as our rule for an arithmetic sequence. Write it down. So this is why we need to discuss the notation, because you need to know what the heck this stuff means. So a sub n, so that's the unknown term we're looking for, the nth term. I can make that n whatever I want it to be. I can make it a to the a sub 1 million. That'd be crazy. Probably won't have to do that, but I can make that n whatever I want. It could be a sub 101. It could be a sub 20. Okay, that n becomes anything you want it to be. What does the a sub 1 stand for? The first term of the sequence. So you take that first term of the sequence, whether it's 3 or 1 or 10, whatever your first term is goes here. Why do you think we do n minus 1? What does this n stand for again? This n and this n are the same n. What does it stand for? Unknown term. Good. So the unknown term we're looking for goes here, minus 1. Why do you think we take away 1? Alex? Because we already have one of the terms accounted for, right? So if I wanted to find the 50th terms, and I'm starting with 3, that 3 is already accounted for. So now I need to focus on the next 49. So that's why you do n minus 1, and you multiply it by the common difference, which is kind of what Marshall was going with. Okay? All right. So now we're going to use that function to come up with unknown terms. Are we ready? All right, here we go. Here's your sequence. We're going to find the 16th term. So the 16th term of the sequence, 4, 8, 12, 16. All right, so let's first start with, what's my n going to equal? Aiden, what's my n going to equal? What term are we looking for? What was this?
16.
Here we go. So my n is going to be 16. My a sub 1 is 4. Now what's d? It's the common difference. 4. Good, because it's plus 4, plus 4, plus 4. So now all we're going to do is we're going to input this into our arithmetic rule. So a sub 16, because that's what I'm looking for, the 16th term, is equal to, what comes first? 4 plus, what goes inside the parentheses?
16 minus 1.
16 minus 1 times 4. Okay, so figure it out. What would be the 16th term? Anna, you got it? What is that?
No, I don't have it.
Oh,
Plus 50.
what's your question?
No, we're not
You okay? Is it 64?
Isn't it times
64.
Yeah.
64.
64.
16 times 4 is 60 plus 4. Oh, yeah.
Now, if you don't believe the rule, feel free to continue that sequence until you reach the 16th term, and I bet you it would be 64. Okay, but that would take a lot more work, right? All right, can you do this one on your own? Find the 25th term. Here I'm giving you the a sub 1 and the common difference of negative 2, so you don't even need to find it. Okay, Casey and Aiden, we don't care. So they give you everything you need. You don't even have to figure out what the common difference is.
I don't really get. What? I don't really get it. I don't even do that.
So there's the setup. Now we just have to do some math. 24 times negative 2 is negative 48. Negative 48 plus negative 5. What is that? Negative 53. So your a sub 25, or your 25th term, is going to be negative 3.
Whoa.
Okay?
I did that way wrong.
Try this sequence.
No,
Negative
you're still using it.
I didn't get it?
No, I'm still looking at it. There you go.
Oh.
I was trying to figure it out.
Can you just. So, yeah.
All right, next one. Here's a sequence for you. Find the 60th term.
Oh, I'm hard. I times by 4.
Okay, Casey, just keep it in your brain.
So, what's going on YouTube?
Wait, that is right.
Okay, guys, focus, please. So we got the sequence 11, 5, negative 1, negative 7. I'll give you the easy stuff. N is 60. A sub 1 is 11.
Wait, what's 59 times 6? I don't know. 59 times 6.
59 times 6.
Oh,
Right now.
60 times 6.
Oh, I got it. Oh, no, 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 no. I did it right.
Negative 6,
Okay, yeah.
right? That makes
Yeah, I
sense.
think so.
So what's happening? What's our common difference? So from 11 to 5, what's happening?
What's N mean?
We're subtracting 6, negative 6. Negative 6, because it's we're adding right numbers. So A sub 60 is equal to
Negative 3.
11 plus 60 minus 1
Negative 343.
times negative 6.
Right? Wait, why would it be times negative 6?
Because you're adding a negative 6 each time.
Oh.
So what are we getting? Negative 420?
No, negative 64.
59 times negative 6. Shh, guys.
It's actually 60, so it's you just.
11 plus.
No, you do the 60 minus 1 times 6.
It's actually negative 343,
Yeah.
by the way.
I'm so
Okay, guys, quiet, please. Order of operations. Work inside the parentheses first. 60 minus 1 is 59. Then you multiply. 59 times negative 6 is negative 354. Adding 11 to that gets us negative 343. Would be your A sub 60. All right, so let's apply it to a word problem.
Kill me.
A bag of cat food. This is the last problem.
Are there word problems on the homework?
Yep. A bag of cat food weighs 18 pounds. Each day the cats are fed, that should be fed, not feed, are fed 0.5 pounds of food. How much does the bag of cat food weigh after 30 days?
Should it be 18 minus 0.5 every time?
Well, you could do that and do that 30 times, or we could use the rule.
No, I'm just saying, like, is that like...
Right, so you're doing 18 minus a half, minus a half, minus half, minus half, minus half. Yeah. So here, what's your A sub 1?
0.5. 18.
A sub 1 is 18, good. My N is 30. We went 30 days. My common difference is negative 0.5.
So what do we do, 30 minus 1?
Yep, inside the parentheses, yep. So set it up. So A sub 30 is equal to 18 plus 30 minus 1 times negative a half.
What does N stand for?
The number of term you're looking for.
So it's gonna be 18? 'Cause that's the number.
Nope, because I want to do it after 30 days.
Oh.
So it was 18 days, and it would be that. What is 29 divided by, or times?
32.5.
3.5?
No, I did it wrong. Hold on. 4.5.
You should be getting 3.5 pounds.